All right, this is 10.2, and in this section, we're going to be dealing with dependent samples, which are often called matched pairs. And we're going to do everything we did for independent samples, but this time with dependent. So first, let's talk about what is a matched pair. How can you tell if something is dependent or independent? If they are matched pairs, then they're you can think of it as like before and after, or two things that are linked. So if we're looking at observations, maybe with fertilizer or without fertilizer. So two things that we are curious how they interact with each other, we're going to use the following formulas and information. If they are independent, recall that you're going to use the formulas from 10.1. So if we're looking for a confidence interval, when we're looking for the difference between the two matched pairs, we're going to use this formula here. Now in this formula, this D bar is the mean difference, and this is the mean standard deviation. And the critical T value there, just a reminder of how to get that. So a manager is interested in improving productivity at a plant by changing the layout of the workstation. For each of the 10 workers, she measures the time it takes to complete a task before the change and again after the change. So before and after, these are matched pairs. She calculates the following summary statistics for the sample differences. So we've got a mean, standard deviation, and the number of trials. Construct the 95% confidence interval for the mean difference, assuming that the productivity variable before minus after is normally distributed. So we're going to grab this formula right here, and that's what we're going to use to calculate the confidence interval. So we've got 8.5 plus or minus, we've got to get this T, right? And then so we'll get that value there. And then our standard deviation is 11.38 divided by the square root of 10. So let's go ahead and grab our critical T value. So our critical T value is T alpha over 2, the degrees of freedom. So remember that degrees of freedom is 1 less than the N. And our alpha, we're talking about 95%. So this would be 0.05 divided by 2. And our degrees of freedom is 9. And so let's go ahead and put that into the calculator, or the Excel, I should say. So we want the equal T, and the probability is 1 minus 0.05 over 2. Maybe you know that value. And so that's 2.26 is our critical T there. So we're going to put that right in there, 2.62. And so we'll calculate that. And so we get 8.5 plus or minus. When you calculate all this, you get 8.14. So that is the confidence interval. And so we can say we're 95% confidence that the mean difference ranges between, and so we can subtract and add 0.36 to 16.64. So that's actually, it's a pretty wide range there. So there you go. Go ahead and give this one a try. Press play when you're ready to see the solution. Just also note here you have the sample variance, so remember for standard deviation you do have to take the square root. All right, and that's the solution. So now let's go ahead and hypothesis test with the confidence interval. So again, we've got to get our null and alternative. We're going to construct the confidence interval, and then we'll make a decision. We'll reject the null if the difference value does not fall in the confidence interval. So this is exactly how we're going to do it. So the mu D, the mean difference, and we'll use the difference value that we're talking about here. So let's do an example. So we've already done this example before. We've constructed the confidence interval. So the confidence interval is from the previous example, 0.36 to 16.64. And so can the manager conclude at the 5% significance level that there has been a change in productivity since the new workstation? So we need the null and alt. So how does the mu difference, what do they want to know? They want to know if there's been a change. So if it's difference. So if there is a difference or not. So this is the claim, right? If there is a difference from before and after. So is this value in the confidence interval? Is 0 in the confidence interval? And so sometimes it's helpful, this value is 0. These are all positive numbers. It is not in the confidence interval. So if it's not in the interval, reject. So we're going to reject the null, which means we can say that there has been a change in productivity. So that's how we can use the confidence interval to make some hypotheses testing and make some conclusions. So there it is written out for you. You can give this one a try. I put your previous example answer from 24A. You already did that. Now go ahead and do B. Press play when you're ready to see the solution. So now let's actually do the hypothesis testing procedure with the p-value approach. We're not going to use the confidence interval approach. So we already know how to do a null and alternative, but we need to know how to grab our test statistic, and we'll use we know how to do the p-value, and then we'll make a decision. So to determine the test statistic, it's just this one formula here, and you can use Excel if you're given data values. Again, just remember that this is how we calculate the p-value. All right, so let's take a look at this example here. Now, this example here, they don't actually give you the data right away, but the problems that you're going to see in your homework do give you the data. So I'm just going to go ahead and very quickly remind you, because this problem can take a little bit of time, but I'll do it a little bit quicker for you. So a nutritionist wants to examine whether the average drink calories declined at a Starbucks after the passage of the ordinance. So they had 40 Starbucks records, and then they want to know at the 5% significance level, did it reduce the average calories? So let's start, if we want to know, we always need our null and our alternative. So what do they want to know? They want to know reduced. Reduced if the ordinance reduced the average drink calories. So let's talk about this for a minute. So did the calories decline? So that means that before minus after. So let's say, what happened to the difference here? So let's say the drinks were at 100 calories before, and then after they declined, so that would be 80 calories left. So that actually means it would be a positive number. But what about if it was 80 before and now it's 100? If you subtracted those, you get a negative number. So if it declines, we're really saying it's greater than 0. So this can be tricky for some folks. So make sure you pause that and replay it if you need to see it again, or try some different answers there. So this is the claim that it declined. Doesn't mean that we say less than because it declined. We have to think about the fact that we're talking about before and after. And you can also look here. If it was 141 before and it went up, notice that the difference became negative, less than 0. But if it declined, 147 to 141, the difference became positive. So in this case, it would be less than or equal to 0. So now for our formula here, let's see what we need to grab. We need the mean difference of these values. So we can calculate the mean difference. So we need the mean difference is the sum of all the values, right? 84 they gave us divided by the number 40. So our sum difference here is 2.1. And in your problems, you'll be given these values, so you don't need to figure them out. We do need to get the standard deviation. You can find the standard deviation actually by doing the sum of all of these divided by n minus 1. And this is way back from before. I'm just going to tell you that and that will give you the variance, that the standard deviation is 8.1549. And again, you'll be given that in your values, or you'll be given the variance and you'll have to find the square root. So we've got these values here, so we are going to find our critical t value. Recall that our degrees of freedom is 1 less. So our degrees of freedom here, it's going to be, and our d sub 0 is always coming from the null and alternative. So it's 2.1 minus 0 over 8.1549 divided by the square root of 40. So our test statistic here is 1.629. So recall that we need to get our p-value, and if it's 1.629, let's look, it's a right-tailed test, so that's going to be shaded. Remember that with t intervals, with t distribution, the Excel actually goes ahead and gives us the right tail. So we want the t distribution of 1.629, and our degrees of freedom is 39. So that gives us a p-value of 0.05, let's just say here, 557. All right, so now let's compare our p-value to our significance value. So our significance value is 0.05. So we've got, they're the same. So if you don't have a digit, go ahead and add a 0. 5 is greater than 0, so our p-value is just slightly greater than, but it is greater than. So we do not reject the null. If we do not reject the null, then we have to reject the claim. So there is insufficient evidence to support the claim that the ordinance reduced the drink calories. And here's it written out for you, and here as well. Give this one a try and press play when you're ready to see the solution. And we'll do the final example in Excel in the next video.